Hello all, I'm Siddharth Kaul and I welcome you to Edupedia World. In this video, we are going to take a look at how to schedule commands and programs in Matlab. The video has been divided into three sections. In first one, I will demonstrate how to use Matlab timer object to schedule the Matlab programs. In the second, I'm going to show how to use the callback function in timer objects. And in third, I'm going to discuss how to handle and resolve conflicts that arise in the timer objects. I will start with what timer object of Matlab can do, and I will provide a very basic example for the same. The Matlab software includes a timer object that is used to schedule the execution of Matlab commands. A timer is set to fire when the amount of time specified by the timer object elapses and the timer object executes the command that has been specified. There are certain steps that need to be performed to use a timer object in Matlab. I have summarized those in these 4 steps. So the first one is that we create a timer object. We use the timer function to create a timer object. Then the second step is specify which Matlab commands you want to execute when the timer fires, and also to control the other aspect of timer object behavior. So here you use the timer object properties to specify these information. Then the third step is to start the timer object. After you create the timer object, you must start it using either the start function or start at function. The last step is to delete the timer object. When you are done with it, it is a good practice to remove the object from the memory, and hence you should use this delete it from the memory. To understand how exactly timer object is created and used in Matlab, I'm going to show a very basic example where I will display some text after a timer gets completed. The example sets up a timer object that executes a Matlab command string after 10 seconds elapse. The example shown here creates a timer object specifying the values of two timer object properties, that is the timer function and start delay. Timer function specifies the timer callback function. This is the Matlab command or program file that you want to execute when the timer fires. In the example, the timer callback function sets the value of Matlab workspace variable status to false and executes the Matlab display command that will show the text timer. The start delay property specifies how much time has to elapse before the timer fires. Start function is used to start the timer object. So when the timer is running, the output will be like shown in small box on the right bottom corner. There will be 9 dots followed by the text timer showing that the timer elapsed at this point. One more thing to add in the code is that always remember to delete the timer object, as it is considered as a good practice. Now let's jump into the timer callback function and how to associate the commands with the timer object events. The timer object supports properties that let you specify the Matlab commands that execute when a timer fires, and for other timer object events such as starting, stopping, or when an error occurs. These are called callbacks. To associate Matlab commands with the timer object event, set the value of the associated timer object callback property. The following diagram shows when the events occur during execution of a timer object and give the names of the timer object properties associated with each event. For example, to associate Matlab commands with the start event, you assign a value to the start function callback property. To associate Matlab commands with the stop event, assign a value to stop function callback. To associate Matlab commands with error events that can happen anytime, assign a value to error function callback, and so on and so forth. Here I have shown how to add a callback function. In this case, I have attached an anonymous function to the timer function callback that will display a greeting after a delay of 5 seconds. So in this I have added first the callback event. Here in this case I have added timer function callback event. You can also add start function event, stop function event, and error function event as well. Then immediately to the event, the handle to the callback function is followed. Here in my case shown here, I have an anonymous function that has statement of hello world that it will display after the timer runs out. Creating a timer object and assigning values to callback and starting the timer object and clearing it can be summarized in these 6 steps that I'm going to present now. However, if you are going to apply the timer objects in your program or use them in any way, these are the steps that will be there in the program. First, there will always and obviously a timer object creation statement. In this, you will be specifying the delay, the execution mode, and the number of tasks to execute. This will always be there in one form or the other. Second is where you will specify, or actually you will be assigning a value to the start callback function. You will be using the cell array as to assign the handle and also pass the appropriate argument with it. In the example shown, I have used the property start function as a dot notation as t.start function and passed my function handle and argument in a cell array. Third is where you will specify or assign value to the stop function callback. Again, in this case too, the value and its appropriate argument is passed in a cell array as the callback function needs to access the arguments passed to it. Again, here in the example shown, I have used the stop function using a dot notation operation as t.stop function and assign it a value in a cell array that contains handle to the callback function and the argument that has to be passed to it. Continuing the same comes the fourth one where you assign a value to the timer function callback. This is the callback that will execute when the timer runs out. Here again I have specified using a dot notation operation as t.timer function and passed my anonymous function to it. The fifth step is where you start the timer. Here you use the start function and pass the timer object t to it. The last step is to clear the object that has been created. I have created a timer object t, and as its use is over, I will use the delete function to explicitly delete this object. These are the only steps you will follow when working with timer object. Outside this, there are no other function associated with the timer object. Using combination of these callbacks, the programmer schedule the execution of commands and programs in Matlab. In cases of multiple execution scenarios where the timer needs to execute multiple number of tasks, the timer may need to add the timer callback function to Matlab execution queue before the previously queued execution of the callback function has completed. Now during this point of time comes the problem of queuing conflicts. In this third section, I am going to cover how to handle these timer queuing conflicts. There is a property in timer object called the busy mode property. This has three values: drop, error, and queue. I will go through each of these three modes. When the busy mode is set to the drop mode, as the name suggests, timer objects adds the timer callback function to the execution queue only when the queue is empty. If the execution queue is not empty, the timer object skips the execution of the callback. For example, suppose here I have created a timer with a period of 1 second, so it will execute every second. But I have defined a callback that requires at least 1.6 seconds to execute. This callback is shown in the right side bottom corner. In my timer function, I have defined tasks to execute as 5, which means that 5 into 1.6, that is 8 seconds, is the total execution time. In the table in the next slide, I am going to describe how the timer manages the execution queue. The table here shows in the drop mode how the timer adds commands to the Matlab queue and how it executes. So it's basically a table of time elapsed and the action taken by the timer. So at the 0 second, when the start timer is executed, the first execution of the callback is started. At the 1 second, the timer object is invoked. So the timer object attempt to start the second execution of the callback. As the first execution is not yet completed, as the time taken for a callback to complete is 1.6 seconds, but the execution queue for Matlab is empty. So the timer adds the callback to the execution queue. At 1.6 seconds of time elapsed, the first callback gets completed and the second gets started. So this clears the execution queue. At the second second, the timer object again gets invoked. So it attempts to start the third callback execution. As the second is not yet complete and is executing, so it will not execute. But the execution queue is empty, so the timer adds the callback to the queue. At the third second, the timer objects again gets invoked. So it tries to start the fourth callback execution. As the third execution is in process, so the as the second callback is in process and the third process is in the queue, so there is no space for this fourth callback. So what timer does is timer drops this fourth callback. At 3.2 seconds, the second callback is finished and the third callback is started, clearing the execution queue. Now comes the fourth second. Here the timer object tries to start another callback execution, but the queue is empty, so it pulls this fourth instance into the callback queue. So this is the fifth attempt, but it's only the fourth instance that will run. At 4.8 second, the timer object, the third callback is finished, and the fourth instance is started, clearing the queue. At fifth second, the timer object again is invoked, so it attempts to start another callback. So an instance is running, but the execution queue is empty. So timer adds the callback to the queue. This is the fifth instance that will run. At 6 second, the timer object will do nothing as we have told him only to execute 5 tasks. So fifth instance and all the fifth instance is already loaded in the execution queue. At 6.4 seconds, the fourth callback is finished and the fifth instance of the callback is started. And at 8 seconds, the fifth callback has completed the execution. So this is how in drop mode, timer executes a callback function that takes 1.6 seconds to execute for a 1 second period, and it completes the whole procedure in 8 seconds. There is another mode in busy mode property, that is the error mode, that is very similar to the drop mode. In both modes, the timer allows only one instance of the callback in the execution queue. However, in error mode, when the queue is non-empty, the timer calls the function that you specify using the error function property and then stops processing. The currently running callback function completes, but the callback in the queue does not execute. For example, I will modify the file that I described in the previous slide so that it includes an error handling function, and I will set the busy mode to error. Here is the table that shows the time elapsed and the action taken by the object in the error mode. So at the 0 second, the first execution of callback will occur. So as the periodicity of the timer object is 1 second, so at 1 second timer object will be invoked. So it will attempt to start the second execution of the callback. As the first execution is not complete but the execution queue is empty, the second callback will be pushed to the execution queue. At 1.6 seconds, the first callback execution gets completed, and this starts the second callback execution. This will clear the execution queue. At second, the timer object will again be invoked and it will attempt to start the third callback execution. As the second execution is running, third callback will not start, but the execution queue is empty, so this callback will be pushed to the queue. At third second, the timer object will attempt to start the fourth callback execution. But the second callback execution is already in progress and the third callback execution is in the queue. So basically the queue is not empty. The timer will not execute this third callback in the queue, but instead will call the error handling function. At 3.2 seconds, the second callback will finish, and here at this point of time, the error handling function will start to execute. The third mode in the busy mode property is the queue mode. If you specify queue, the timer object waits until the currently executing callback function finishes before queuing the next execution of the timer callback function. In queue mode, the timer object tries to make the average time between execution equal the amount of time specified in the period property. If the timer object has to wait longer than the time specified in the period property between the execution of timer function callback, it shortens the time period for subsequent executions to make up for the time. This concludes the video on program scheduling in Matlab. In the next video, I'm going to talk about the performance of Matlab program. So until then, please subscribe and thanks for watching.